Okay, we're live. Hi everyone, this is Dhruv from Spaceonova. All those of you who already logged in, tuned in, thanks for joining us. We'll be waiting a minute so that people can join in, and then we'll begin. Sorry for the delay, some technical issues, but they're all sorted out now. Okay. By the way, if someone can touch others here as of now. Seems like most people have left because of the delay. I've lost connection with Sir. Hello, Sir.
Yes, I can hear you.
All right, cool. All right. So, all those who are watching us, if you can hear us and see the presentation, then please let me know in the comments below. All right, cool. So, let's start. So, hi everyone, once again. Sorry for the delay. My name is Dhruv from Team Spaceonova, and I have with me today Mr. Debadatta Mishra. He's a senior at ISRO and has extensive working for a whole host of projects for ISRO. Just a little bit of background about him. He graduated from Berhampur University in Odisha in 2004 in the mechanical engineering branch with a first class honors, and later obtained his MTech in aerospace engineering from IIT Kharagpur, right? And his career has spanned more than 15 years. He started in 2005 at DRDO. He's also currently he's working at ISRO on various projects such as the Gaganyaan study team and so on and so forth. He's a life member of the Aeronautical Society of India, Bangalore, and has also published a lot of technical papers in reputed journals. So it's really great to have you here, sir. And
Thank you.
yeah, so I guess let's just cut straight to the chase. I would it's all yours, sir.
Thank you, Mr. Dhruv. So, with this brief introduction, let me thank you, all your team members, for giving the pain, taking the pain, and arranging this cumbersome effort to spread the space knowledge and education with the mass comprises of students and working peoples. And I also, on behalf of all the team and you people and myself, I also um, deeply apologize for this technical delay, because that's not in our hand. A lot of internet glitches, all this problem happens usually. So shall we start discussing with this technical talk?
Yes, sir. Sure, sir.
Shall I start? Yeah. So thank you. Thanks again. My dear friends who are listening me and seeing my going to see my presentation. So on this occasion of World Space Week, let me congratulate all of you who are sticking to their monitor and were curious to know like what is this presentation and what is this talk I'm going to give on interplanetary mission. What is it? What does it mean by? Whether is it relevant to us or is like any other topic is just for like uh, means fantasy kind of discussion. No, it's a very serious topic, and here I want to convey one more important message to the student body who are listening me now. Uh, Let us not always hope for कि after graduation you should go for a 9 to 5 kind of job. Instead of that, always keep a mindset that ki you can contribute to the society also by establishing some business, by establishing some entrepreneurship. So in that way also you can contribute. And the space sector, which is very virgin in its nature now in India, and it's slowly opening up. So many more opportunities are there, and where a lot of growth potential is there. And if you people can think into that, so tomorrow I think India can produce many Elon Musk, and India is having the capability and the capacity. And here our knowledge and intellectual level is not lesser than anyone across this globe. That much confidently I can say. So let us keep that point in the mind. And in my presentation, I have not included any mathematical formula, no mechanics, no physics, nothing. So I have just kept it as simple as possible, like a fairy tale kind of story, so that it will generate curiosity and interest among you all. And tomorrow you can take this concept into a research mode, or you can try to develop something which will be directly or indirectly will be used in this field, in this interplanetary exploration. So let me start. So the name is Interplanetary Mission. Why this interplanetary kind of thing is required? This is, even though I'm given the name topic as interplanetary, but I'm not limiting here with the planets, even asteroids, comets, other other than our solar system. What are other planets are available outside also? I will give some gist on that. So before that, I just want to brush up our fundamental knowledge what we have studied in our academic, either in school or in preschool time. So we know in our solar system, we are having these many planets. these are these planets is divided into basically two parts. One is inner planets and another is outer planets. So who we address inner planet, those are Mercury, Venus, Earth, Mars. They are called inner planets and they are very close to sun. And those planets they're far away from sun, those are called outer planets. Those are Jupiter, Saturn, Uranus, Neptune. And yes, of course, some years back Pluto was there in our family, but it has been driven out because it did not meet all the planets specification. So there is international astronomical body, so they decided not to include, but rather they designated as a dwarf planet because it does not meet all the requirements of a planet to be declared as a full planet. So other than this, our sun is a star, we know, and these planets, these 8 planets, they're revolving around our sun in their particular orbit. And but other than that, there are like unknown number of stars in our galaxy and in other galaxy. So there is also one planet called 187123. This planet was explored by International Astronomical Union, and they found it is also circling a star. This thing, and it is very similar to Jupiter, and the star they identified as 187123. Why is it specifically mentioned here? Because the planet is very similar to Earth. There is hope that that is also having water and life can sustain there in that planet. Then a very fundamental question arises when we start talking interplanetary mission. What is it? Why it is required? Anyhow, I quietly, happily settled in this earth. We are enjoying our life. Everything is evidently available to us, be it water, be it oxygen, be it our loving foods. Everything is available. But still, then, why this kind of thing is required? What is going to impact our life in the coming days? My dear friends, we know global warming. That is the biggest hot topic nowadays, where a lot of unforeseen natural calamities are coming, be it cyclone, be it the water level in seas increasing, so low laying areas, those will be immersed in water in the coming years, maybe another 10, 15 years. That's the thing the atmospheric scientists they predicted. They're quite worried about that. And now we can see winter is shrinking, summer is the duration of summer is increasing, and terrible hot we are feeling even in the month of November, December. So many of us who are in mid 40s, they can remember when we were kids, when we were child, in our childhood days, even in the month of April and May also we used to feel the cool breeze. But now all these things are vanished, is completely depleted, all these things. So we are wondering what happened. So knowingly or unknowingly we have done a lot of damage to the environment, and it is the outcome, is the reaction of the nature. But anyhow, that is not the topic of our discussion today. So who knows, maybe down the years, after 50, 100 years, so the climate may become unbearably tough for us to live in this earth. That may be on the reason we have to find a suitable place before these bad days knocks our door. Then population. So population is alarmingly and exponentially is growing across the globe, and that consumes a lot of resources, and natural resources are depleting in a faster way. And we know we cannot replenish the natural resources on our whim. It takes its own time. Like you cannot generate this petroleum gas or ores in the mines by doing some magic. So it has happened in the course of time, and again same time it will take again to replenish. But again we cannot have any assurance on that. What we'll do then if all these things gets over, the in the basic need, that is our water. You are able to read in everyday newspaper, there is a lot of uh, 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 misunderstanding and what you call, like, fight among our own neighboring states with neighboring countries. They want to take control of the river what is flowing through that part, that demography. So it's also drying fastly, and without water we know we cannot survive, without oxygen we cannot survive, without food we cannot survive. So everything is drastically coming down. So these are the few things which is matter of concern for us. Other than that, we know there are a lot of asteroids which have in the near past they have come very close to uh, enter our Earth atmosphere, somehow with a thread length. It is paired. It did not come there and did not hit. My friends, you might have known a billion of years back when dinosaurs were extincted. So it is a theory. It is a theory is that a big asteroid it came and hit the Earth and created a lot of havoc, and those dinosaurs and that creatures, whatever, those got extincted. So those kind of dangers are already hovering around us, and those are beyond our control. We cannot do anything about that. Um, so keeping time in hand, we have to find a habitable place other than our Earth. It can be a Mars, Venus, or any other planet in our solar system, or beyond our solar system. And if it will be announced that in the coming 1 week or 10 days time, one asteroid is coming to hit the Earth. So within a week or 10 days, we cannot develop a technology to leave the Earth. So we have to start the things now. And already a lot of research and developments are happening. Not now, since last 30, 40 years. And the results are tremendous. And in the coming years, is going to definitely is going to help us. So, as I told you, even though the topic I've given interplanetary, but yes, we are not going to stick to only planets. Even there are a lot of natural moons of our own planets, which can be habitable. For example, Titan is a natural moon of Saturn, and with extensive research, they found that in Titan there are lakes, rivers, and liquid bodies, and but those liquid are not H2O, rather they are methane. So methane lake, methane pond, methane rivers are there in Titan. And what we have to do with methane? And, we cannot we cannot use anything of methane. Yes, but you know very well, methane is we can use as a propellant, and by electrolysis process we can divide hydrogen from that, and we can convert it into water by adding oxygen, which you can artificially produce there. And moreover, one small example I want to give here. See, why we are born and brought up in earth, and our forefather, like billion years back, when the life evolved in earth, that was evolved on oxygen and on H2O. But assume in that billion years back, instead of oxygen and H2O, if there would have been some different gas and different combination of chemicals here, so today we would be consuming and inhaling those only. So in that way, I can say in Titan, living creatures will be there, maybe there, and they are growing and living on the methane. So it's not necessary that in all these extraterrestrial bodies, whatever living creatures are there, they only should live on oxygen and water only, because every planet is having its own natural environment. So whatever creature will be living there, that will be living based on that availability of resources in that particular planet or particular extraterrestrial body. So that's the reason I have listed few moon name here, and human interests are there, and a lot of researches have been going on, like Euclides, Europa. Europa again is the moon of Jupiter. So here a lot of hope is there. Yes, here we can go and survive, and here the environment is habitable for us. So as I told you, like if you want to go a foreign place, how we can live there? Assume you are from India, or you are from India from some place from Himalaya, nearer to Himalaya. So you will be living in a very cool atmosphere or cool environment, and suddenly it will be called for you to go to some place in Sahara desert, which is very hot, and then definitely it will be difficult for you to go and survive there. But however, you cannot get an excuse not to go there. But thing is, you can take some cooling system, cooling equipment with you. Even though it will be very hot outside, you can create a artificial environment within your habitable area, and you can live comfortably there. So same thing applicable if you are from um, Rajasthan, desert place, from Rajasthan or some other part of India, and if it will be called for you to go to Amazon, which is full with greenery and a lot of humidity, so you can also artificially create one environment there which will fit to your body, and you can adjust there. So that provision is there. So like that, if you are at all, if it is called for you to go to other foreign planets, and where it will be required for you to go and stay there and generate your habitat there, then there are two options. Either you can carry all your required thing along with you, like water, oxygen, food, and a comfortable environment where you can live happily. You can generate that, but for that you have to carry a lot of things with you, a lot of stuffs, a lot of equipment, a lot of machines, machineries, everything you have to take. Or alternately, you should know how to change that environment according to your requirements. So that is called terraforming. For example, Mars, with a lot of research, they found a lot of carbon dioxide is there on the atmosphere of Mars. But yes, we cannot survive on CO2 environment, but a plant can survive, a tree can survive, a algae can survive. So we can put those things there. They will absorb the CO2 for their usage, and they will release the oxygen. So slowly one oxygen environment will be built up there. So that is called terraforming. There are many ways you can change the environment, and is a very exhaustive and long term process. Then, second point, human settlement on other planets can become fully and permanently independent of Earth only if those alien worlds, those exotic worlds or planets are transformed to create Earth-like living conditions. What I told you, like we need food, we need water, we need oxygen to survive. Then only we can think of how to grow and how to establish ourselves there. So Earth-like environment, if you want to create in that planet, so we have to take a lot of equipments, machineries, and maybe number of trips you have to do, because we so far we have not developed any high capacity launch vehicle, or what we call like rocket, to carry all this equipments at a once. So it is economically, as of now, it's not viable. But yes, of course, a lot of research developments are going on across the world with government and private participations, and days are not far away. He will come to know that benefits, and we can develop such powerful transportation system. But why interplanetary mission? Still, again, it will be you people will be wondering. No, I'm not convinced. Whatever he's saying, we are not convinced. We are very happy. We are very content, and we are okay with our planets. Where we are staying is good for us. Best place so far we know. Yes, I also agree with you, but as I'm telling you, this giving example of different planets. So Mars, we all are reading that in Mars, they found water moistures and ice and this thing, that thing. But what drove Mars to this level? It become a desert now. Not there is a single sign of any living creature there. What happened there? If we'll understand what is happening, what happened in the past there, if we understand, then at least we can take proactive action, and we can preserve those things in our mother earth where currently we are staying, currently living, and our next to next generation, or down the line 100 200 years or so, we are going to stay here. So in this way, studying other planets, other terrestrial, extraterrestrial bodies, at least we'll understand what is the things happen there, and by knowing that, we can take those action, proactive action. We can study how things are evolving, changing here, so we can avoid it. We can avoid it. We can avoid it. So again, let us come where we are staying as Earth. So it's a very fundamental question. Earth is the only world we know that supports life. Yes or no? Yes, many people from us will believe yes, there is, if life exists, that exists only in Earth as of now, and we do not have any proof or evidence that still life is there other than Earth in any of the other places, other planets, or other moons, or any other extra celestial bodies. But is there extraterrestrial life beyond Earth elsewhere in universe? Maybe we don't know, because still we are trying to find out. It is possible that there is or has been other life in our solar system, perhaps on Mars or Europa. But to find intelligent life, astronomers are looking much further away. People like us, I told you, we are very happy. We used to be content with our present situation. But many people, they are not happy. They are not satisfied what they have. Always they look for more, beyond. So there is a case, astronomers, they are always staring to the sky in the night. When we sleep, that time they wake up and they see towards sky. They want to see what's there in the sky. What sky wants to give any signal to us, whether any life exists there. So in that way they try to find out, and then they say yes, some hope is there, some ray of hope is there, ki life may be there, or if it is not there at all, how we are thinking, but it is still it is exists there, or we can go there, or we can establish there, we can create a habitable place there for us in the coming years, maybe after 50 or 100 years or 200 years. What do you mean by interplanetary mission? Is it a pure science or technology, or what's there? So in a simple way, interplanetary mission is a voyage or a travel or a trip through outer space involving one or more than one planet by means of space technology. When I say space technology, it needs a launch vehicle or rocket. We need spacecraft. We need lander. We need rover. We need artificial environment so that our astronauts they can live in that environment, and they can travel and they can reach a place. So interplanetary mission, it consisting of all these things, and either it can be done by human space flight or by spacecraft. Human space flight means how NASA send Apollo mission to moon, and now again they are planning by 2024 to send same astronauts, and we are having International Space Station, and many other countries, they are also in the race to establish their own space station, and the where astronaut can go stay, they can do the research, and from there it can become like a temporary halt. From there again they will take a long journey to different planets like Mars, Venus, or Moon, or any other extraterrestrial bodies. So or else if we have we do not have any adequate knowledge about that particular planet, then first we can send the spacecraft, what we have been doing since last 30-40 years. So many artificial spacecrafts, artificial moon or spacecraft has have been sent to different planets and their moons. They are revolving, they are sending a lot of information data to us. By analyzing that, there are a lot of hopes arising in the scientific body. Yes, tomorrow we can find a very suitable place somewhere other than Earth, and we can go and settle there. If any eventually it will happen here in this Earth, if or any big problem happens here. Interplanetary mission aims at traveling to various interstellar bodies and studying them at close up. Yes, what I told you. So interstellar body can be either a planet other than Earth, or a natural moon of any planet, or a comet, or even an asteroid. My dear friends, you will believe or not, there are so many asteroids which are revolving around Sun, and they contains lot of valuable noble metals what are very scarce in our Earth. For example, platinum and titanium. And you will not believe, astronomers, they have found a lot of asteroids, they are having a good amount of water in them. The origin, I don't know, maybe a lot of research happening. Then some asteroids are there, they are full of diamonds. So imagine tomorrow you will go explore an asteroid and you'll find that there are a lot of diamonds and a lot of other stones, rare earth stones are there. So you can imagine, if you bring to Earth, you will become a millionaire, billionaire within a short time. Okay, that's I'm leaving up to you people to imagine today and to see the dream. Okay, today night you'll dream that you have already reached those asteroids and you are collecting those precious metals and materials from that place. And interplanetary mission, as I told you, can be made in a two-way: either physically going there, sending a spacecraft, or through scanning the sky with powerful telescopes. So there are a lot of powerful telescopes are established across the globe in collaboration with scientific bodies, and every night they are hopping to the sky, they are staring to the sky, and they are figuring out, they're trying to figure out what kind of scopes are there, like what kind of stars, moons, planets, and any body is there where they can get a sign that yes, some chances are there, the life is there, or it can be converted into a habitable place if at all we can come there. So when you do any mission, first we have to outline the objective. Simply a mission cannot be accomplished without any objective. Like when we start something, always our elders suggest us, first you keep your target, your aim neat and clear and loud to you. It should be visible to you after this many time or these many years, why you will be reaching what you want to do. So like this, any interplanetary mission, it needs some scientific, it divided into two parts. One is scientific objects, one is technological objects. Scientific objects will do scientific experiment, research, but technological object will convert those research into a usable platform, so that the benefit of research can go to the can be used to help the society, and it can be used to the used for the cause of common man. Like we want to go different planets, we want to explore, we want to see. What for? because for our own survival, for the survival of our civilization. If tomorrow any accident happens, or if Earth becomes uninhabitable in 50 years, 100 or 200 or 400 years time, before that we should have a backup with us, where we can say confidently, yes, we can go there, we can stay there. So scientific objects, what we need, surface features. Yes, is a very important features. If surface is not strong enough, it cannot withstand the load of anything. So it will become like what you call, like um, very loose, and it cannot hold any of our foundation there. Morphology, how how the life evolved in that particular planet, if at all, if it is there. Mineralogy, yes, what kind of metals and minerals available. Surface, as I told you, surface features. And atmospheric composition, yes, if atmosphere is there or not. If it is there, then what is the composition of that atmosphere, whether it contains oxygen, whether it contains nitrogen, whether it contains CO2, or any rare elements like what you call, like xenon, helium, krypton. So those things are required. And suitability for existence of living organism. If at all we are coming there, can you stay there? For example, Venus, they found phosphine in the atmosphere, but the Venus cloud, Venus is covered by the sulfuric cloud. So we cannot go and stay in a sulfuric environment. The pressure in Venus is 95, 96 bar, which is beyond imaginable. We cannot survive at all there. The moment you will put your foot outside the artificial your vehicle, space vehicle, within fraction of a second you will become powder with 96 bar pressure when it will act on you. So those kind of things, by sending satellite and by lander sending rovers, we can find out, and we can do the research and analysis sitting in the earth. Then technological objective, yes, to develop and demonstrate deep space communication. These are our technological objects, because when you want to plan for a travel to go to Mars or Venus, then we have to have our space communication, developed space communication, because um when I speak now, within a fraction of second, you people are able to hear me. But when I speak now, and you will be sitting somewhere in Venus and Mars, it will take 7 minutes going and 7 minutes coming. That is called occultation, because a lot of planets are there in between. Through that, the sound will get disturbed. The communication will get disturbed, because communication we do through electromagnetic propagation. So we get disturbed. So we have to develop, because for example, if your friend, your astronauts are there in Mars, they are facing some problem, and by the time the message will reach Earth, and we will respond, it will take 14 to 15 minutes, and we don't know by the time what would have been happened to them. So we have to overcome such kind of technological developments, limitations. Yes, navigation, mission planning, and design. These are must. For example, in Earth, if you want to travel one place to a unknown place, you are using GPS. Like that, if you are going to travel from Earth to a unknown planet, or a moon, or on any extraterrestrial body, then you must have a proper path how to go there. Mission planning, like when you plan to go someplace, you put all these things in your backpack, and you plan for a week stay or for a month stay, and you plan like how you will go. Either you will take your own vehicle, you will go, or you will go by train, or you will go by aircraft, or by other mode of travel like by sea. Hmm. So those belong to mission planning. So that comes under technological objectives. And design, yes, of course, you have to design your complete system. You have to architect the complete mission. And you always should have backup plan, like plan A, plan B, plan C. If it happens, what we have to do, because when you are thinking of going to a unknown place, and you are having very limited knowledge or information about that place, so always you have to be double, triple, and quadruple prepared for that. So those objectives should be very clear and loud to you. Then types of interplanetary mission. So interplanetary mission, as I told my dear friends, we can send satellites, we can send astronauts, and we can send lander, rover. So flyby, this is orbital mechanics part. Flyby means, in a very layman language, I'll tell you, every planet or every element in this solar system is having their own gravitational acceleration. It may not be in the range of 9.81 what we are experiencing here, but it will be in the more or less, or maybe in a very minimal number or maximal number. It exists with all the planets. So when you will send some artificial thing to that planet, so when it will go to that sphere of influence, that planet will catch it with its gravitational pull. It will catch it, and when you will try to escape that gravitational pull, means like when you want to escape from that sphere of influence, then it will exert a push force on you. So by using that natural push force without consuming any of your energy, you can get some momentum, and you will again travel in your on your way to reach your destination. So in that way, we can send a spacecraft aiming for Saturn, but on the way it can go through other planets, Jupiter, all this, that, and that can get the energy or that push force from those planets. And on the way also it can do some experiment on that planet, even though it is not our desired planet, but on the way it can do some experiment without spending much of our energy in that. We will get the information. A small example I'll tell you: if someone wants to travel from Bombay to Chennai or Bombay to Kolkata, it can stay halt on the way. It can replenish food items, water, fuel. How we are stopping our vehicle on the way, getting refueling from the fuel pumps. So like that, we can do, and we can refresh. Then we can start the journey. That is the reason, with international cooperation, one gateway is getting built around the moon. So where astronaut can go, they can stay there. It's like a temporary halt for them. They can refresh, they can go down to the moon, they can collect the water, energy, fuel, everything, and they can start their long journey to Mars or Venus or other any interplanetary bodies. So that also will be, will rejuvenate the things. Then orbiter, yes, we can send a spacecraft to a particular planet, and it can orbit around the planet, and with its onboard payloads, we can measure the temperature, the surface temperature, the pressure, the mineralogy, the atmospheric condition, everything we can study by sitting on Earth, by using that spacecraft payload, and through that electronic instruments, we can get all the details about that particular planet instead of going physically there, and which will help us to build our future projects. Lander, yes, as I told you, my dear friends, lander. So lander is nothing but like it will go and sit there, and it will be a stationary laboratory for you. It will not move anywhere, but by using that onboard instruments in the lander, you can do the excavation, you can do the lot of research by taking the nearby photographs. You can send it to Earth through the lander, and it will have its own instruments. So through that it can sense what is there in the atmosphere, but it will be stationary. You cannot move it. And the soil seismology, if any earthquake, anything is happening, like in Mars, they found there are a lot of earthquake is happening in the Mars. So they are investigating, because we know earthquake is very dangerous for any structure, and to withstand that kind of seismology, we must build a foundation, must build structure which can withstand those kind of vibrations. Rover, yes, is kind of a robot. Is a mobile, so it will go and it can travel, it can cover any distance on that particular planet or particular extraterrestrial body, asteroid or comet, and it can give those data. Instead of at single place, it will give the data around that place. So this kind of missions we can plan. Then again, this is orbital mechanism, transfer orbit. As I mentioned you, when you want to go from one place to another place, there are several options available to you. Either you can travel some distance by train, then some distance by bus, some distance by boat or ship, and you can reach. And you can remember when there was no GPS, when you want to reach a new place, always you used to ask passerby, dear sir or madam, how we can reach that place? This is the address. Then it will show you, go left, go right, go straight, and they will give some landmark. If you see that temple or something, some tree or something like that, then you will feel that you have almost reached that destination. So these are the different kind of trajectory design, different kind of transfer orbit, how we can go and reach a planet or an asteroid. I am skipping this. So where is World Space Forum with respect to interplanetary mission? Whether we are talking standalone or whether I am saying something which sounds very fantasy kind of things. It means is nothing like that. No, my dear friends. A good number of robotic interplanetary missions have already performed by space agencies like NASA, Roscosmos, JAXA, ESA, our very near neighbor, our friend Chinese Space Agency. So they have already done a lot of research, lot of findings they have found, but unfortunately those informations are not easily available to the scientific body, because still the space, every country is working in a standalone manner, but collective cooperations is going to happen in the coming years, because they are very well understood alone is not easy to conquer the space. So collectively all the country, they have to work together. After all, this is the matter of our own survivability. So unless until we work together, we cannot succeed in this. Our very own space agency also has been doing this lot of research. I think this is regularly getting published in the medias, so I don't have any more thing to say on this. So now we'll become astonished, we'll become amazed, surprised. These many interplanetary missions are already carried out. If you start counting, more than 100, you will not believe. Yes, of course, some more failures are there, but can you imagine what kind of and what amount of work has been happening in this interplanetary field? So I'm just keeping this. Then I will just give you a little more view on Mars. Everybody is talking about Mars. Why? What special is there in Mars? Why that is a point of attraction for us? We can think of any other planet, but my dear friend, there are two distinct points what I mentioned here, and other than that, so many other points are there. But due to the paucity of time and limitations, I have avoided putting everything here. To your query, the answer is the inner planets left of Earth are very close to Sun, possessing huge temperature range like Venus. I given an example, Mercury, and their pressure is such that human structure itself may collapse. Like I told you, the pressure on Venus is 95 to 96 bar. What is the pressure on Earth? 1.03 bar. 1.03 bar, you are not able to feel. But when you will become 96 bar or 95 bar, the moment you will expose to that kind of pressure, you will finished. You will become powder, or maybe beyond powder. On the other hand, if you think of outer planets right of Mars, away from Sun, those planets do not have a solid crust like surface or land mass. Like if you go to Uranus, Neptune, those they do not have any surface or land mass. Rather, they are filled with morphous kind of things. So, and the temperature is very less in the range of like cryogenic temperature. So, the survival on that place will be too difficult. Whereas Mars, if you see, more or less all the temperature, surface temperature, pressure, and a little close to our Earth atmosphere, there its atmosphere also more or less matches with Earth. So that gives a good hope among the scientist community. Yes, of course, if we do little more research, and definitely we can find a solution and we can go and settle there. So what is required? Interplanetary mission requirements. Yes, now you decided you want to go Mars. Yes, Mars is a habitable for us, and we can take some equipment, we can do some terraforming there, and yes, we can establish there. But how to go there? So as I told you, there will be different mode of transportation when you plan to go from one place to another place. So that mode of transportation is up to you, how you can choose. If you want to comfortable, you can go by two-wheeler or four-wheeler, or maybe like different mode, like by airplane. And or if it is a if you have to reach that place by a ship on water, you can go based on the feasibility and available transportation. So like propulsion. So propulsion enables, propulsion helps us to move from one place to other place. It's nothing like an engine. And propulsion, if I give you example with respect to your automobile, many people, they are using petrol engine in their vehicle. Many people, they're having diesel engine vehicle. Many people nowadays, they're using electrical engine vehicle. So that's up to you. Like if you want to cover 1,000 kilometer, of course you cannot rely completely on electrical engine, so you have to go for a petrol or diesel, which is easily available on the way, you can refill. But however, in case of space propulsion, chemical and electrical, as of now, both are two predominant propulsions. Those are used. Yes, of course, a lot of researches are happening on implementing solar propulsion, nuclear propulsion, and non-conventional kind of propulsions. But those are still in research mode only, and it will take little time before they will become reality. And by using this kind of thing, yes, of course, we can reach any planet. As of now, it will take some time, but yes, we can reach. Then sustenance. As I told you, where you want to go, if that place environment is not as like as Earth, so you have to have complete adequacy in your design, in your thinking, to face any eventuality there. So because as I told you, spacecraft, or you want to send your astronaut, that environment may not be much suitable to them. So and any unforeseen dangers may be there, and we don't know, on the way we may have to face some space debris, and it may create damage to the complete system, and which will create endanger our system, or endanger our astronauts life. So we have to keep everything in our mind, and accordingly to design our system. Power source, yes, of course. When you're traveling, just I'm correlating our day-to-day life. Yes, all these things we ourselves we are doing every day. When you are planning to go a different place, new place, always you are keeping a lot of backup in our mind. So power source, when you're taking a mobile, and if you feel there won't be again a recharge point, so you are taking a backup with you, backup charging system with you. So like that, when you are thinking to travel 50 lakh kilometer, 1 million kilometer kind of distance, so of course you have to generate and you have to store your own power within your own system by using solar panels, or using any nuclear power source, like this radioisotope thermoelectric generator, which very predominantly have been used in interplanetary missions so far. So this kind of thinkings are required. Then orbit insertion. Yes, when you have reached near to a planet and you have to go nearer to that planet, so that's called orbit insertion. Orbit insertion, in a very layman's language, I'll say, you have reached the destination, you have to knock the door and you have to enter the room, like that. So for example, you have to go to the Saturn, then on the way Titan will come. So through Titan, you can correct your path, that is called course correction, and you can enter to the orbit of Saturn, maybe 100 kilometer, 200 kilometer from Saturn, and you can capture the requirements. When we send some spacecraft to Mars, it directly does not go to the Mars. It takes a course, and we call this like we have to insert into trans-Mars insertion, and it will follow the Mars, and when it will reach that planet, then it will do the braking by using onboard propulsion. Then and with our own designated commands, which will be feed into its onboard computer, it will enter to a predefined orbit around the Mars. So it's called orbit insertion. Development of launch vehicle. Yes, this is a very important thing. If you do not have a very powerful rocket, you cannot take many more things. So again, limitation will come, and those limitations will jeopardize your mission. So for that you need powerful launch vehicles, and as of now a lot of launch vehicles have been developed which can carry 150 200 tons of equipment to lower earth orbit of 200 kilometer and beyond that. And a lot of research still going on which will help us to take many more uh, uh, beyond that orbit. Yes, just I have listed down what are the future interplanetary missions have been planned, other than our regular sending satellites and other stops. So India is planning Venus, all these things. I think those are coming in media. So I'm skipping that. World Space Forum is stepping towards manned interplanetary mission. Yes, as I told you, Artemis mission, NASA is planning, ESA is planning, Chinese people are planning, so JAXA planning. So a lot of space agencies across the world they're planning. And NASA proposed this Orion multi-purpose crew vehicle. By using their space launch system, they will go to moon and beyond that, means to Mars and other planets. It's a long-term project, and coming years is going to happen, and we all will going to witness such kind of achievements, which will be made by our friends from other space agencies. So with this, I will try to conclude. I think I might have sparked an ignition with you people. So it will force you to think from today or tomorrow onwards. Yes, where we are is not a permanent place for us. Many of us, if you see, just a very small example, currently where we are living, whether we are born and brought up on those places, no. We born and brought up at some places and we migrated due to some reason in the search of livelihood, search of opportunity. So like that, today or tomorrow, same thing is going to happen with us who are in the earth as a whole. So it will bound us to think, yes, earth is not a permanent habitable place for us. Keeping time in our hand, we have to think another one habitable place where you can go, where you can settle. But that will not happen within a week or a month or a year. So a lot of research, lot of thinking process has to be put into that. Then only we will come out with a solution. So I'll just read out. Necessity is the mother of all inventions. Yes, is a very fundamental things everyone we know. Today, what we have been using, today what we are using, what kind of life we are living, everything has been developed because at some point in the past we felt, yes, it is required for us. Example is the mobile phone. Now everyone, irrespective of their economical background, everyone is using a smartphone. But imagine 10, 20 years down the 20 years in the back, in the past, hardly anyone was having this phone, mobile phone. That time it was considered as a luxury. Now it is a necessity. And can you imagine if someone will tell now completely you stop mobile and you start using same conventional cable phone, how many of you will agree with that? Definitely none of you will agree to go back to the old system. You see television, you see automobile, you see medical technology. The old days, with a simple flu, many people used to die. But now you see, we are courageously, we are saying, we are confidently, we are saying, yes, we are developing, we'll develop the things and we'll change the future. So this necessity will compel us to think about the alternate habitable place. And yes, the down the line, coming years may not 2021, but 2020, 30, 2050, or 2100, we will be somewhere other than this mother earth. And whether we are doing, we want to do this interplanetary research work only just to move out of earth. No, my dear friends, no. If you do this interplanetary mission kind of study research, it will enhance our knowledge over ignorance of these traditional planets of our solar system. My dear friends, I do not want to hurt anybody's sentiment, but still we are worshipping planet Mars, planet Saturn. Just imagine, tomorrow you will be living in Mars, whether you will worship that planet. This is just in a lighter vein I am saying you, like that. So we will understand what is there, and we can go there and we can see what's there exactly. Established proven science and technology. My dear friends, many of the things right now what are using, those are the spin-off which have come out of the space research. For example, this lithium ion battery, this air conditioner, this washing machine, this what you call GPS. All these things are initially developed for space exploration only, space research only, and later those have been become commercialized, and now we are seeing how much it is benefiting us. So without a mobile, or without a air conditioner or washing machine, life will become terribly like what I can say, like we cannot imagine, or we cannot think of not using these things. And yes, as I told, replenish the existing resources over Earth. How we can replenish? Just I'll give an example. There is a very rare gas available on the moon. They have found out by the scientific experiment, that is called helium 3. So if you bring the helium 3 by fusion process, you can generate energy which you can convert into electricity. And a city like New York, it can survive for 25 years. That they have done the research with 1 kg of helium 3 gas. Can you imagine this kind of means potentials are there? And as you told, you asteroids and a lot of mines, metals, minerals are there. If we can explore, and if we can bring back to Earth, and we can use it, definitely we can get a lot of benefit out of it. Yes, last but not the least, expand human colonization beyond Earth. Yes, that is what I have been trying to convey to all you ladies and gentlemen who are listening me. So yes, that is again more and a very vital part of this topic, interplanetary. And yes, we need this, but what we have to do to achieve this? We need a most powerful and reliable launchers. Launcher means what I mean to say, space launchers. We need powerful rockets which can enable us to go to take a lot of equipments, machineries to that orbit, and from there, by using onboard propulsion, we can travel and we can reach those extraterrestrial bodies, and we can do a lot of research. And reliability, yes, in space, when you talk, reliability is a must. 0.99, 0.98, 0.95 kind of reliability is must to create confidence. Because when you'll be sitting in a vehicle, and if you are very sure, if an accident happens, you will survive, then happily you can go and sit. But if you will come to know, if accident happens, it's a very less probability you will survive, then always there will be a fear factor in you, and you will always avoid not to go there. So when you are talking about human beings, you are going to send them, so reliability is a must. Yes, economic and advanced propulsion system, as I told you, like when you go to market and purchase a vehicle, always you ask, sir, what is the mileage? There's a common phenomenon among us, common thinking among us. If with a less fuel, if you can travel more, then people always go for that kind of system. So here also same thing applicable. My dear friends, one thing I want to make it very clear to you all: space science or space exploration is nothing like completely different subject. Is more or less related to what we are studying and have been studying, and what we have studied in our college days or in our school days. So it is just a subsystem, those physics, chemistry, and mathematics what we have studied. So with this, I am concluding my speech in this golden opportunity of World Space Week. And my dear friends, you do know or not why we celebrate this World Space Week? Just I'll give a hint to you, just a point to you. 1957, October 4th, the first artificial satellite was laid, that is Sputnik 1 by Russia. So in remembering that achievement, because that achievement was not limited to Russia, and that opened the gateway, they opened the door, the window for us to explore the space. So since that day, we people become enthusiastic, curious to know about the space. And to remember that particular day, we have been observing this World Space Week every year from October 4th to 10th. This is the significance of this week. And before ending, I'll just read out a few lines. I think you almost all, everyone you know this great man, late Stephen Hawking. So he's a great advocate of this interplanetary exploration. He's a great physicist, we know, theoretical physicist. Also, he has spent a lot of money in this interplanetary research work. He has donated a lot of his Nobel Prize money. And what he has quoted, just I will read his lines. These lines are made by him. I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet. But I am an optimist. We will reach out to the stars. Yes, let us make this dream come true. If man had already proved surviving in space on space stations, then why not on alien planet? There's nothing that when you proved in the harsh space environment we can survive by making artificial habitable place in the space in the mode of international space stations. Then what's big? Why we cannot go and stay in other planets? Yes, something we have to make there. We have to convert this to a habitable place. Yes, of course we can do it. So my dear friends, with this I'm concluding. I don't know how much I touched your mind, how much I disturbed your mind, or how much I created the vibration in you to think this interplanetary kind of things, whether it is required or it's a fantasy kind of thing or is a fairy tale of story. But yes, of course, definitely I'm very sure today night you cannot sleep in a peace of mind. It will create turbulence in your mind, and it will force you, it will bound you to think, yes, what is told, if not 100%, but 60-70% is absolutely correct. We have to do this. Keeping time in our hand, we can do this. And my kind request to all the people who are listening me, take this subject as your future research topic, and and develop something which can be directly or indirectly useful for this. Create some entrepreneurial real mindset, develop something, establish some setup, and directly or indirectly contribute here. Don't always confine yourself with ISRO, DRDO, all these kind of jobs, because many people, they approach me, they ask us, sir, how to crack the exam. So instead of that, you always diverge your field, not converge. Keep your options more and more, not less and less. So with this, I am concluding my speech, and I'll be very happy to take few questions from you. Thank you. And here, one more thing, I just thought of saying you, coming years, maybe not now immediately, these planets and moons what you are seeing will be become our own, what you call, like family of moons and planets. I'm very sure after 50 years or so, when people will think of going for a vacation or a picnic, instead of going to any place in earth, they will think of going to Venus or Mars. And your relatives also will be settled in Titan or Mercury. So in puja vacation, or in Durga puja or Deepavali time, you can you can plan of going there and spend, and you can think of spending 1 week or so with them in different planets and Venus. And my dear friends, keep in your mind, this is the reality going to happen, if not immediately, but down the years is going to happen. Keep in your mind. And some reference these I have used. Thank you very much. So with this, I am handing over this thing to the host. They can guide further.
All right, thanks a lot, sir, for that presentation. And I'm sure that all the people watching us right now enjoyed it just as much as I did and found it just as engaging. Um, at this point, if anyone, there haven't been a lot of questions so far, but if anyone has any questions right now, people who are watching us, please feel free to enter them in the comments. I'll wait a minute for that. So, sir, I'd like to ask something that in your okay, wait, hold on. So here's a question that I'm sure you had lots of times. There's a person here asking, if I want to work for ISRO in fields like orbital mechanics, what should I be doing after finishing my BTech in mechanical? What course do I take? So basically, just the trajectory that one might take after an engineering degree. what would you recommend to them?
See, engineering degree, what I mean to say, is a gateway for you to explore what are the options available, and that is the reason I told you. Let us not concentrate only on ISRO or how can I join ISRO. You can, instead of that, you can think space sector. What I can contribute, or how I can work in the space sector, because when you talk about space sector, that's a very vast field. So definitely you can accommodate yourself in any of the branch, be it a propulsion, be it a astrobiology, be it a astronomy or astrophysics, or you can go a number of opportunities are there in the space sector. So always you look for a bigger perspective, not a smaller or converging kind of things. And yes, of course, after graduation, you can join ISRO, you can join any other government organization which are doing directly or indirectly into engineering research. And yes, of course, you have to clear some competitive exams and interviews. These are the normal process in India. I think these you will get definitely from different sources. And I don't think I can tell you any bigger or any specific mantra. If you recite that, and you will clear that. So certainly you have to do study hard, and fundamentals. You should understand the fundamentals of engineering rather than by hurting the engineering concepts. If you see the
Right.
inventors, they
Right.
were not big engineers. Rather, they invested their time in understanding the logic, the fundamental of the things. If it's a James Watt, or the inventor of relativity, Einstein. So like that I can say at this moment.
Right. So there's a question here on asteroid mining. What are your views on asteroid mining for interplanetary travel? And just to add to that, I'd also like to ask, what is ISRO at all looking at something along these lines, asteroid mining and such? So just
Yeah,
share your
asteroid
general
mining as a
opinion on
whole,
this.
I'll say lot. Yeah, a lot of promises are there. Even Elon Musk also, as I think in some of his interview, has also told one asteroid name I forgot that contains a lot of this thing, our platinum material, and he wants to discover it. And he's saying that in the coming years, one in some experimental this setup you want to do there in that asteroid, but I could not remember that name of that asteroid. Some name is there of that asteroid. And not only that, so many asteroids are there. I told you, it contains a lot of rare earth minerals and metals like diamond, and uh, you know or don't know, I don't know. Thing is, we had a lot of stones to avoid some planetary influence on us. Like our astrologers will say, you wear this panna, green stone, red stone, yellow stone. A lot of things you might have observed. Many people, they use it to wear. So those kind of stones are also, a lot of stones are there in different asteroids, and those can be brought back to Earth. And yes, that can generate a good amount of revenue here, and many people can become crorepati by selling those stones here. So a lot of opportunities there. And yes, ISRO has been doing, but again, it's a government body, so anything it used to come in the media and all these things. So I think whenever it will come, yes, you people will get a chance to know and read that. So uh, at this moment, I think I'm not the right person to say anything on that.
All right. So there's one more question here. So, sir, you've talked about interplanetary missions for in this presentation. There's a question here asking whether there is any feasibility in intergalactic missions
Yes, of course.
at any
See,
point of time.
yes, possible. Only thing is you need a very efficient and strong propulsion system, because at the end of the day, which will propel you or which will carry you, that is propulsion system only. You must have a very robust and efficient propulsion system, and there is a reason. See, 100 years back, anybody has imagined that today how we are traveling, the mode of transportation or travel would be like this. Whether anybody had dreamt of it? No, na. So today we have developed and we are traveling in the speed of Mach and Mach number more than 5, like supersonic, hypersonic, those kind of things we are using in our transportation system. So I don't think it will be a difficult or impossible task. Yes, it will take some time, and there's a reason antimatter propulsion system they are developing. Antimatter will help you to travel long distance with a very good velocity. So within that, I think with a short span of time, you can reach any other intergalactic body, because our lifespan, if you take maximum 60, 70 years, so with 60, 70 years, definitely we cannot reach any light years beyond our capacity. So to travel a long light years, our travel time should come less. Then only we can reach. So those are different topics, and it needs a lot of discussion and deliberation. So I don't think this platform will allow us to discuss infinitely today. So there's a different topic.
Yes, of course, of course. Yeah. So I think at this point, since there are no more questions and we're also running out of time, I think at this point we will end the discussion, the session. And once again, sir, thank you very much for taking the time out and giving us this presentation, giving us this insight into this fascinating topic of interplanetary travel. Uh, like I said, extremely engaging topic, and it was an absolute delight to hear you talk. Very inspiring. So thank you very much, sir. And I
Thank
would
you.
also like to thank. Yeah, yes, sir.
No, I just said thank you to you.
Okay. I would also like to thank all the people watching us. Right? Thanks for tuning in and watching this presentation. And I'd just like to remind you guys that we will be having a whole lot of other talks like this, master classes and so forth, going on over the next few weeks. And you can visit our website. You can stay tuned to this YouTube channel and check out all our socials also for information on these events. So yeah, we'll get back to you with another event on some equally engaging topic in space sciences. Till then, thank you and good night.
Thank you, Mr. Dhruv. And thank you all.